are meanders? How are they formed? So meanders, like an answer, explain that these are zigzag river courses. They are best formed on flat, very gentle, extensive plains. The mechanism of meandering is not well known. It is related to conservation of angular momentum and related to depositions by the river. Exact mechanism not known. Keller suggested the following stages in meander development. Stages क्या हैं? Number one, a straight river with sides depositions called as shoals, S-H-O-A-L-S. A river, there are depositions here, there are depositions here, there are depositions here. And remember, the shoals are alternate. It's not straight line में. Sides में होता है, they called as shoals. They are alternate. The shoals broaden and riffles and pools are also formed. So what are riffles? These are also one type of depositions. Pools are more like depressions. Shoals will become larger and riffles and pools are formed. Riffles are like depositions. Pools are more like depressions. The water depth is a bit more on the pools. So this is the river. The shoals have become larger. The shoals have become larger. And there are some deeper parts called as pools. And there are depositions called as riffles. There are pools and there are riffles. The side mein hai, these are called as the shoals. Then what happens is the river now takes a sinuous path. Slowly, gradually, the river will take a sinuous path. Sinuous path where the pools are on, the pools develop on the convex side. The pools develop on the convex side. And riffles are formed in between. So now the river has taken a zigzag path. The distance, pool to pool or riffle to riffle, the distance between two pools or the distance between two riffles initially is about 3 to 5. It then becomes 5 to 7 times the width of the river width times the mean width of the river. So remember, see, we are trying to write down the keywords. And finally, the river meandering. The next one, so 3. The next stage says that the river meander can sharpen, making prominent horseshoe shaped bends. And they can also be formation of oxbow lakes. So in this case, what happens is the river has now taken a very sharp bend like this. In some cases, we can also have oxbow lakes. Okay, so you have some diagram on page 404 also. Now, one point you can add in this: meandering rivers are a type of channel pattern for alluvial channels. Alluvial channels means the rivers that are flowing, rivers flowing in softer alluvial plains. These are not rivers on hard rocks. Meandering happens when the sinuosity index is more than 1.5. So what is this? This is equal to length of channel by length of the valley. Basically, if this is the river, if I calculate or I measure the length of the river along its deeper points, and if I have a straight line from the terminus to the head, this dotted line, this is called as the length of the channel, and this is called as the length of the valley. This is LV and this is LC. So if I draw a straight line from the head towards terminus, and the line along the river, this is along the river. This is called as channel length. And this straight line is called as the valley length. So sinusity index is equal to length of channel by length of valley. Meandering, according to Davis, is a feature of late mature and senile stage when downcutting is very slow, the river is large, and the gradient of the slope has almost flattened. And this happening when the river is near the base level. Davis says so. Davis says this happens when the rivers are near the base level. Page number 424 and 425. हालांकि 425 में थोड़ा सा mistake है. It says that for SI more than 1.3 it meanders. Okay, so it's not 1.3, it's 1.5, not 1.3. Page 425 में it says SI more than 1.3 it meanders. You keep it as more than 1.5, not 1.3. And next one, factors affecting meandering. Factors like the slope of the landscape, the volume of discharge, and type of geomaterials. The slope of landscape, the volume of water discharge, okay, and geomaterial. Volume discharge, here we'll talk about the rainfall, the precipitation. So meandering is a feature of large rivers, moving sluggishly, slowly, and performing depositions. Agar depositions nahi hoga, the turning is not sharp. Okay, so we have taken care of meanders. What is channel pattern? Okay, channel pattern. This is feature of alluvial channels based on type of material and sinusity index. So there are many schemes. Okay, there are features of alluvial channel. What is alluvial channel? Rivers that flow through alluvial plains. So if you remember channel types, what are channel types? We have bedrock channels and we have alluvial channels. Bedrock channels, these are rivers moving over harder rocks. Okay. Alluvial channels, rivers over alluvial plains and alluvial deposits. Bedrock channels, examples are the rivers of the peninsular plateau. Alluvial channels, examples is the rivers of the northern plains. So there are two types of channels. So there are, the following are the patterns: straight channels, sinuous channels, meandering channels, and to this you can add braiding channels and anastomosing channels. Straight channel, SI is 1.05, sinuous 1.05 to 1.5, meandering more than 1.5, braided channel more than 1.5 plus large amount of sediments. An anastomosing channel is a special type of braiding which is stable. So I hope you know what braiding is. Braiding is when a river moving starts breaking up into branches and sub-branches. This is called as braiding river. When the braiding channels don't shift anymore, when the braiding channels get fixed, stable, then we call that as anastomosing channels. Don't confuse these three words. What is channel type, what is channel pattern, and what is drainage pattern. Drainage pattern is subsequent, consequent, radial drainage, superimposed drainage. Okay, we have the trellis drainage. वो drainage patterns हो गया. Channel types हैं bedrock and alluvial. And channel pattern is what I'm explaining here. Channel patterns means based on sinuosity index, and drainage pattern is trellis, superimposed, consequent, resequent, subsequent, and go on there. Look at page number 412, like anastomosing channel pattern. So anastomosing channel pattern is a special type of braided pattern. There is multiplicity of channels, multi-thread pattern. Look at the last 3 lines. It says many channels, but they are stable and retain their identities. That is, the channels do not get obliterated. The channels don't keep on changing. Once the path is made, the river keeps flowing in that path. I can have one case where the river breaks up and the river keeps on changing, sometimes like this, sometimes like this, sometimes like this, sometimes like it keeps on changing. This is unstable. Unstable braiding. Auric hai, the river has broken up, okay, and the channels have become stable. The stable ones are called as anastomosing channels. Next concept is what is the grade of a river and factors affecting it. So grade is a state of a river. Grade is the condition of a river. A condition where the net erosion is balanced by net deposition, and the river performs the role of transportation. The sediments carried by the river equal the transportation capacity of the river. The sediments carried are to the ability of the river to transport. Basically, imagine this is a river. Say the transportation capacity is 5 units. This is a river. Say the transportation capacity of the river is 5 units of sediment. Transportation capacity that is dependent on some energy of the river. If the transportation sediments is 3, so 2 amount of energy is not used. So this 2 energy will start eroding. But if the transportation capacity is 5 and the sediments that we have are 9, then 5 will be transported and 4 will be deposited. So in this case where the transportation capacity was 5, the sediments to be transported were 3, the extra energy left, 5 minus 3, 2 is used for erosion. So this river performs the role of net erosion. This river, it can transport 5, sediments are 9. So the excess sediments 4 gets deposited. So this river performs the role of net deposition. A condition where 5 can be transported and 5 are present. Then the river uses its energy to transport. There is neither net erosion nor net deposition. So what we have is, that is, the river is in a state of equilibrium. It is in a state of balance. And this balanced state is called as the river grade. The river grade is considered to be hypothetical. Why? Because in reality, such a state has not been found. It is a kind of mathematical possibility. It's because of the mathematical extrapolation. And this idea was given by Gilbert and also used by Davis. And according to Gilbert, the typical shape of graded river profile is an open concave, a broad open concave like this. This is the graded state. All of these, like small short notes, they can ask you, or you can use in your answers. According to Davis, grade is a possibility in the late mature stage. And what are the factors? So factors include the initial slope. The factors include the amount of discharge or the water. The factors include the type of sediments, and the factors according to Davis includes time or the age of the river. Now you can add one point of conversation here is, now equilibrium state of grade is a condition where a river does not perform net erosion. It's a state, I said, where the river has attained the state of equilibrium. Now this condition is the equilibrium state of grade, okay, where the river does not perform net erosion. Now what I'm saying is that in Davis model, the idea that river grade is a function of late mature is a type of contradiction, because if you remember, Davis model is an example of closed system. In a closed system, a river cannot stabilize before it reaches the base level. So the assertion of graded state in late maturity is a type of contradiction. Okay, if this is the base level, the river is moving, the river can achieve stability only when it hits the base level. Only then can net erosion be equal to zero. But Davis is also saying that in late mature, somewhere here, the river has achieved equilibrium, which is not possible. So this looks like a contradiction of what Davis has said. It is page number 388, right up to 391. But it's better if you keep the notes on this topic. So what is river capture? And discuss the types of a river capture. What is river capture? It is the process by which a larger river invades and annexes the course of another river. You define it. River capture is a common process for rivers which flow in the youthful stages. Basically, fast moving river and a high eroding river. Now, in terms of what are the ways by which it captures, there are three ways. One is called as the process of headward erosion. We have the process of lateral erosion, and we also have the process of meander capture. Lateral erosion is something like river shifting. So headward erosion, the river starts cutting backwards. The river flows like this. The river starts cutting backwards. So another river flowing here, it cuts backwards, goes and bridges the river divide, and this river starts flowing like this. Okay, this is what is happening for youthful stages. Lateral erosion, this was the river, another river, this river starts shifting, and maybe captured by this river eventually. Okay, lateral erosion. This has shifted, and it has been captured. This has happened for river Tista. River Tista used to be a tributary of Ganga. Now it is captured by the main trunk stream of Brahmaputra. So Tista has been captured by Brahmaputra. And the third is the meandering. So this is one river, and this river starts meandering. It meanders and it can capture because of the meandering. So in this case, it can be either ways. Okay, it can be the lateral river which captures, or it could be the main trunk that captures. So if the main trunk, then this can get captured like this also. So that depends on which has captured which one. It can vary in terms of size. It can vary in terms of the amount of water. In the meandering, the river meandering is so sharp that another river here probably comes on the meandering path, and this river entirely has now turned like this. And this now becomes the misfit river. Meandering is a special case of river lateral erosion. So page number 348. Capture through intersection of meanders. If you refer to 348 and 349. Okay, so types of capture, it says Look at the page 349, first column and the second paragraph. The last 4 lines it says, thus the forms of river capture may be grouped into 3 categories: captured by headward erosion, captured through lateral erosion, and captured through intersection of meanders. So it talks about a river called as Tons River has captured the course of COT. So your example है, river Tons has captured the lower course of a river called as COT. COT, which is near Allahabad city. An example आपने दे दिया है. So again, 1.5 page write-ups. Okay, these type of questions, we just want that you are aware of these questions. So practice this much. This is the range of landforms that they can ask you from the processes.